Alright, hello everyone. I'm Jaron Vietor. I'm from DDVTech. We make MistServer, which is a media streaming toolkit. And today I'm going to talk about our load balancing solution. But before I begin, I'm first going to give a quick introduction to load balancing in general. I assume that most people here are already familiar with load balancing, but just in case, load balancing is necessary because servers have limits. And you can't remove those limits. I mean, there's always going to be a limit at some point. And load balancing is a solution that avoids those limits by spreading the load over multiple servers, so that if you're running out of capacity, you just spin up a few more servers, you balance the load over those, and if you need more capacity, you start more servers. Wash, rinse, repeat. Well, it also doubles as an early warning system, because if you can see that you're running out of space on your service, you know that you need to take action. So it serves a bit of two purposes. Now, current strategies for load balancing are either DNS-based or client-side usually. There's a few more, but those are the two big generic ones. The DNS-based load balancing uses a host name that sends to multiple servers, while client-side load balancing has a list of servers on the client side where the stream is being opened, and it picks a server using some technique. Now, techniques to pick a server, both for DNS and for client-side, there are several techniques to pick from, and that's the second item here. You can actually measure the load on a server and send loads to whichever server has the most room, or you could use round robin, where you just go server 1, server 2, server 3, and repeat. Or you can use random assignment or some other technique. Practically everyone has their own favorite flavor or favorite method to load balance. So why would you change the existing load balance techniques, and why specifically for media? Well, I have a little basic graphic here. The three dots, you can imagine those are streams. The rectangles, those are servers, and the triangle there at the bottom is a viewer. Now, if that viewer wants to watch that first stream over there, usually what happens is this connection gets made. The viewer connects to one server, that one server connects to the one stream, or the other way around, and the viewer gets to watch. Now, this is obviously the most efficient way that you can connect, because it's as direct as you can get, except for possibly leaving the server out completely, which is not an option, of course. But things get a little bit more complicated when you have two clients connecting. Now, if you have two clients, you can have a spread like this, where each client connects to one server and both servers connect to the same stream. But it's also possible to have this connection method, where both clients connect to one server and that one server connects to the stream. Now, in both cases, both this one and this one, they are theoretically the most efficient, because in both cases you have either one client per server, or you have one server per stream. So it's efficient, but on a different side of efficiency. Now, things get a little bit more complicated when you go to multiple viewers, more than just two. Let's say that you have 4, and and 2 of them want to watch that first stream, and 2 of them want to watch that last stream. Now, if they're spread like this, that can work quite nicely, because you have 2 viewers on each server, and each server is connected to one stream. That's nice and efficient. But if you set if your balancing happens wrongly, what can happen is that this connection gets made. You still have 2 viewers per server, but each server has to connect to both of the streams. Now, this is clearly not the most efficient anymore, because in this case, both servers are requesting both streams, when if you had spread the viewers over the servers differently, you would have been in this situation where there's less connections and less bandwidth being wasted. It gets even more interesting when you have a whole bunch of clients arriving all at the same time, because most load balancers have a small delay before they change what action they're taking. So if all 16 of these are connecting to the load balancer will think, okay, well, both servers are empty, I just sent them all to the same place, and this will happen. And that first server gets overloaded, and after it's overloaded, it goes down. Then all those people reconnect, they go to the second server, and the second server goes down, and before you know it, your whole network is down. It would be much nicer if the load balancer knew what was going on, that many people were going to be arriving, and instead made this spread, where half of them go to one server and the other half to go to another, and they both connect to the stream. Sure, you have a double connection to the stream, but at least this way your servers are not going down. So, MistServer's load balancing fixes all of these things by using a combination technique of passive monitoring, just like traditional load balancing, where the balancing node keeps track of all the servers and how well they are doing, how much people are connecting, stuff like that. But there's also a proactive algorithm that predicts the load before it arrives. And it combines this algorithm with intelligence from the passive monitoring system to make accurate predictions. So how does this work exactly? Well, it works by the balancing server keeping a constant connection with all the servers it's balancing and checking their health. If the connection goes away, it assumes that most likely the server is having issues, or if it's getting slow, then we know that the server is probably also getting slow. It also actively gets the information about current CPU use, bandwidth use, RAM use, all that stuff. It penalizes and rewards servers in the internal balancing algorithm to sort of make sure that the servers that are most healthy or the emptiest or whatever combination works get the most load. But it uses that current load on the servers to estimate what the load per viewer or per stream is. So if a new viewer comes in or if a new stream starts and something is connecting to there, it can already estimate, okay, well, we have 5 streams now, let's say a fifth of that is probably used for each stream. Or we have 1,000 viewers now, let's say 1,000th of the resources in use is probably used per viewer. And then if, say, 100 people are added, it knows, okay, that's probably 10% more than I'm currently doing. Let's proactively already assume that that load is going to be arriving there soon, because I just send it there. And then that way you get a very accurate prediction of future load. Now, it gradually overrides this prediction with actual measurements to account for errors and people that didn't really connect or that stopped watching, and changing network conditions. Because it's possible that a server that was doing fine, now there's an issue, or maybe some cable someone tripped over. So things can change. So we gradually override the predictions with real measurements, and it sort of balances out. Now, if you want to get more information about all this, there was actually a research paper written on this way back in the middle of 2016. It's posted on our website. If you go to MistServer.org, click documentation, and then the research paper Q2 2016, you can read all about it. We also compare it with a state-of-the-art load balancing algorithm that has been published. And we do all kinds of cool tests and comparisons, so you can use that to get more details, because this explanation was obviously a little bit on the short side to keep it accessible. You can also ask us, we're MistServer/DDVTech, our booth is over there if you're here. You can ask us to try the beta version, because this is not public yet, because we're still in testing stages. It is being used in production by many of our customers, but we'd like to get a bit more feedback before we publish it for everyone. So you can ask us to be in there. Or you can, of course, contact us. You send an email to our generic info address, and you can get more details. Now, maybe there are some questions. It looks like probably not. Well, if someone wants to ask questions later, I'll be here, and later on I'll be at the booth. And if that's all, then that was it.